All right, so we're going to do a little bit more graphing with systems. Give you a few more examples to work with as we've been going through this week. So I have three systems I'm going to go ahead and graph for you. So here I have 3x minus y is equal to 6 and negative 4x plus 2y is equal to negative 8. Now both of these are in standard form, so I'm going to do xy tables for each of these for equation 1. And then I'm going to do an xy table for equation 2. I'm going to use intercept for 1, and let's see how it turns out. So if I go ahead and make x 0, that means my first part of my equation here disappears. Okay? So I'm left with negative y is equal to 6. Now I can't solve for negative y, so I have to change both my signs. It's multiplying or dividing by negative 1, however you want to think about it. And I'm left with y is equal to negative 6. All right? And go ahead and put that there. Then I'm going to go ahead and substitute in 0 for y, which means this is going to disappear. Okay? And that leaves me with 3x is equal to 6. Divide by 3 on both sides. That cancels. X is equal to 2. And these are two nice whole number points, so I'm going to go ahead and work with those. I'm going to go ahead and work with the second equation now. All right, so I am also going to use intercepts. This looks like it might work out real nice. So I'm going to start off with x is equal to 0. If x is equal to 0, this disappears, right, and leaves me with 2y is equal to negative 8. If I divide by positive 2, y is equal to negative 4. Then I have my first point. Now I'm going to go ahead and substitute in 0 for y. That's going to allow this to disappear, right? And I'm left with negative 4x is equal to negative 8. Now, when I have a negative in front of my coefficient and I'm dividing out, I want to go ahead and take that negative with it, so I'm dividing by negative 4. X is equal to, now negative over negative gives me a positive. 8 divided by 4 is 2. All right? And I can go ahead and graph using my intercepts. All right, so I have 0, negative 6. I have 2, 0. And this is line number 1. Go ahead and connect them. And label it line 1. All right, then I have 0, negative 4, 2, 0. And it looks like I actually had my solution in my intercepts. This line 2. And my solution is actually right in both my charts, 2, 0. All right. Let's go ahead and look at another example. I have 3x plus y is equal to positive 1, and 2y equals 2 minus 6x. Equation 1, I'm going to go ahead and just do an xy table. I might do something different with equation 2. I'll look at that when I get there. All right. So equation 1, going to get its own xy table. I am going to make y 0. No, I'm not. I'm going to make x 0. Which makes this go away. And I'm left with y is equal to 1. Now, I really don't want to make y 0 because I don't want a fraction. I don't want to have to graph a fraction. So I'm going to keep working with the x value, and I'm going to go ahead and make x 1. If x is 1, I have 3 times 1 plus y is equal to 1. This is going to be positive 3. I'm going to subtract 3 from both sides. and y is equal to negative 2. And those are two nice points I could go ahead and graph. Right? Now for the second equation, I'm going to go ahead and do something different for the equation number 2. It's almost in slope-intercept form. So if I could get this in the form of y equals mx plus b, I could just graph it using the slope and the y-intercept. Right? So I'm going to go ahead and solve for y. And I'm going to do that by dividing by 2. And if I do that, I have to do that to all the pieces. Okay. This 2 is going to cancel, leaving me with y is going to be equal to 2 divided by 2, which is 1, minus 6x divided by 2 is 3x. And it's almost in slope-intercept form. I just have to do a little bit of rearranging. So y is equal to negative 3x plus 1. All I did was switch these two up. Okay? So my intercept is 0, 1. And my slope here is negative 3, or negative 3 over 1. And I'm going to graph using this idea. So these are my points for 2. And let's go ahead and set up a graph. I have 0, 1. Draw some hash marks here. And I go down 3. And to the right one. Now this line should be going down from left to right, so I've got to make sure that my slope matches my negative here. And this is line 2. I'm going to go ahead and graph line 1 using the intercepts. So I have 0, 1 and 1, negative 2. Those are the same 2 points. Here's 0, 1. Here's 1, negative 2. My graph actually lies right on top of the one I have. These are the same line. Okay, so my solutions for this, any point that lies on either one of these lines. All right, let's go ahead and look at one more. So I have negative x plus 3y is equal to 6, and 3x minus 9y is equal to 9. They're both in standard form. I'm going to go ahead and give them each their own xy table. And I'm going to go ahead and start with making y 0 for number 1. If y is 0, this goes away. And I'm left with negative x is equal to 6. Again, I got to go ahead and multiply both sides by negative 1, or basically just switch my signs. X is equal to negative 6. All right. I need another point. I'm going to go ahead and make x 0. That means this whole piece, including the sign, is going to go away. And I'm left with 3y is equal to 6. If I divide both sides by 3, y is equal to 2. And I have my 2 points. All right. Going to work with equation 2. I'm still going to do an xy table because it's in standard form. If I go ahead and make y 0, that gets rid of this along with that minus sign. And I'm left with 3x is equal to 9. Divide both sides by 3. X is equal to 3. Going to do the same thing for my x, going to make it 0. When I make that 0, this piece goes away. I'm left with negative 9y. The sign has to stay with that 9y is equal to 9. Divide both sides by negative 9. Ooh, what is that? That cancels, the sign cancels, and I'm left with y. And a negative divided by a positive is a negative, and 9 over 9 is 1, so I got negative 1. I'm going to go ahead and graph this line. I might want to extend this out a little bit. There we go. And I have 6, 0. I'm going to make my lines a little smaller. I'm running out of room. So negative 6, 0. 0, 2. And I have 3, 0. And 0, negative 1. And these lines appear to be parallel. In fact, they are. It just doesn't look so like it according to my drawing. So these lines are parallel. When they're parallel lines, there's no solution. So I hope that helped you out a little bit more with graphing systems, and we are going to talk about an algebra way of solving for the next lesson. So go ahead and practice, and I'll see you in the next video.